Hello good people, I'm going to talk about representing chemical reactions. The image in the upper left represents iron chains and then some rusty iron chains. Recall that this represents a chemical change. And it turns out that chemical changes are a result of chemical reactions. A decent follow-up question would be, what is a chemical reaction? A chemical reaction represents breaking and forming of bonds. Another way to say that, and this is very important, that during a chemical reaction, atoms are neither created nor destroyed, but they are rearranged. This is known as the law of conservation of mass. A lot of chemistry depends on this law. But how do we represent chemical reactions? We use chemical equations which indicate the substances involved, their states, and their amounts. Let me explore this image in the upper left. This chemical change where iron turns to rust. It is a simple enough statement based on many observations. Yes, iron will turn into rust. But what makes it turn into rust? The wizards with the black hats or the space goats? Some of you might go, hold on, you demented cauliflower. Iron doesn't just turn into rust. It usually happens in presence of air. I could then say that iron exposed to air will turn into rust. But what is it in the air that causes iron to turn into rust? Well, it turns out it is oxygen. And so now I could say that iron exposed to the oxygen in the air will turn into rust. How can I represent it using chemical formulas? Here we have Fe for iron, O2 for oxygen, and Fe2O3, which represents rust. Let me name these substances properly. Iron is fairly simple, but for oxygen, note that we are using molecular oxygen. Recall that in chemistry, when we just say oxygen, we are thinking a single atom of oxygen, whereas when we say molecular oxygen, we are talking about the covalent compound of oxygen, O2. We have iron, a metal, and molecular oxygen, a non-metal, reacting together to give us an ionic compound, iron oxide. All of these substances on the left-hand side of the arrow are known as the reactants, while all of the substances on the right-hand side of the arrow are known as the products. Arrow itself is known as the reaction arrow. What are these little letters in yellow? They indicate the state of matter. The little s represents a solid, an L represents a liquid, a G represents a gas, and an AQ indicates aqueous, which means that the substance is dissolved in water. Currently, this chemical reaction equation has a bit of a problem. Recall the law of conservation of mass. Right now, on the left-hand side, I have one iron atom, while on the right-hand side, I have two. In a similar fashion, I have two atoms of oxygen on the left-hand side and three atoms of oxygen on the right-hand side. Seemingly, I have created atoms. Remember, we cannot do that. Atoms are neither created nor destroyed. They are simply rearranged. So to make everything balanced, we need to add a few coefficients. Coefficients are placed in front of the chemical symbol or the molecular formula or the formula unit. They indicate the amount of substance. And very importantly, they make sure that the equation is balanced. They make sure that we follow the law of conservation of mass. And I can quickly check it. On the left-hand side, I have 4 atoms of iron. On the right-hand side, I have 2 times Fe2. That is also 4 atoms of iron. On the left-hand side, I have 3 times O2, that is 6 atoms of oxygen. And on the right-hand side, I have 2 times O3, that is 6 oxygen atoms as well. And so at the end, when reading this balanced chemical reaction equation, I could say that 4 atoms of iron react with 3 molecules of oxygen to give 2 formula units of iron oxide. Recall that when we talk about ionic compounds, we talk about formula units. And when we talk about covalent compounds, we talk about molecules. Please note that while this chemical reaction equation is balanced, and it shows how iron and oxygen can combine to give iron oxide, there is more to this process. For all of this to occur, we also need water to be present. This would be a reaction condition. And often, reaction conditions are placed either above or below the reaction arrow. In summary, chemical reactions are represented by chemical reaction equations. The substances on the left are known as the reactants, the substances on the right are known as the products. A complete chemical reaction equation indicates the state of the matter, and it also obeys the law of conservation of mass. It does that by including coefficients that make sure that the reaction equation is balanced. That is all for now, and I will see you on the flip side.